Hello dear viewers, welcome to the part 2 of the lecture series on weldability and welding metallurgy of Cr-Mo Steels. Well, in this part we are going to discuss about the weldability of grip resisting steels. Uh, for Cr-Mo steels, in order to take the full benefit of the strength and property of the material, the Cr-Mo steels have to be post-weld heat treated because as weld martensitic structure is very high and the martensitic structure has to be tempered, and the carbide particle size and their dispersion is to be managed to maintain the grip strength. There are traditional P11 and P22, P11 and P22 grades. They are now being substituted by P91 and P92 grades for supercritical thermal plants. This Cr-Mo steel is having air hardening property. So, and due to their high alloy content, so their weld metal demand correct welding procedures that includes preheating, post-weld heat treatment, low hydrogen consumables, and right weld deposit composition to prevent heat affected zone and weld metal cracking. So for Cr-Mo steel, the practices like preheating, post-weld heat treatment, use of low hydrogen consumables, and right weld deposit composition is very much necessary to prevent heat affected zone and weld metal cracking. This table provides some guidelines on recommendation on the preheat temperature in degree Celsius. So for the composition half chrome half moly to 9 chrome 1 moly, for the thickness of range less than 12.7 mm, between 12.7 to 57 mm, and greater than 57 mm. The recommended preheat temperature are tabulated here. As you could see that when the composition become richer in chrome moly, for the higher thicknesses, the preheat temperature is minimum 150 degree Celsius. And for 9 chrome 1 moly steel and 7 chrome half moly steel, it is 200 the preheat temperature. Now welding of Cr-Mo steel post-weld heat treatment. So Cr-Mo steels, especially in pressure piping, have to be stress relieved as required by the relevant codes. So depending on the size and geometry, these welded joints are either local stress relieved or sometimes they are wholly stress relieved in a furnace. They are locally stress relieved by means of a thermal jacket. So in the next slide, there will be a table that we give some recommendation on the stress relieving temperature, and that must be below the critical range. It means they must be below the lower critical temperature, and that should result in reduced hardness and residual stresses level, and at the same time should increase the ductility of weld metal in heat affected zone. So here some recommendations on the stress relieving temperature in degree centigrade of materials like half chrome half moly to 9 chrome 1 moly steel. The temperature ranges are mentioned here, but it must be understood that this temperature should not exceed the tempering temperature of the steel. So if the temperature range cross the tempering temperature, then we don't take the benefit of the strength. So because these materials are air hardening in nature, so the moment they cross lower critical temperature, they again transfer back from austenite, and with a conventional cooling rate in steel air, they obtain hardness and their property will be deteriorated. So in subsequent slides, we will try to understand this phenomena. Well, reheat cracking of chrome moly vanadium steel is also a phenomena that happens during the stress relieving heat treatment, particularly in chrome moly vanadium steel. If the chrome moly vanadium steels are having a coarse grain heat affected zone, upon heating, the fine carbides form within the grains, so they make the strong grain stronger than the grain boundary. So under the stresses relaxation process, this grain boundary, weaker grain boundary cannot withstand the stresses, and the grains are separated out of each other. So this is known as reheat cracking, or sometimes known as post-well heat treatment cracking. Now to assess the susceptibility of the reheat cracking, there is a parameter known as cracking susceptibility. It is known as CS is equal to percentage chromium plus 3.3 times the percentage molybdenum plus 8.1 times percentage vanadium minus 2. When we uh, put the values of this composition chrome, moly, vanadium, if the value CS value is greater than 0, then cracking occurs. So how to get away from this reheating cracking problem? First is to control the chemical composition. It means, chrome, moly, and vanadium. Lower this uh, chrome, moly, and vanadium percentage, lower be the risk of reheat cracking. Then low restraint joint design, because if there are more mechanical restraints, then under the restraints, the stresses are very severe. Then multi-pass welding or low input to avoid the grain growth, because grain growth has to be controlled, because this particularly reheat cracking problems occurs due to coarse grain size in heat affected zone. So this table gives some selection on the electrodes for creep resisting steel. Now American Welding Society classified electrodes for different weld composition: 1 quarter chrome half moly to 9 chrome 1 moly, suitable for typical ASTM base material. They are recommended for ASTM A335 pipe material P11, for A213 tube material, for A335, for A387 grade 91 plate material. So here E7018B2-B2L, here E stands for the electrodes, 770 is the kilopound per square inch, so 70,000 pound per square inch. 1 is the welding position, flat, horizontal, vertical overhead, except vertical down, and 8 is the type of coating, and this B2, B3, B4, these are the chemical composition of the deposited weld metal. Here the table gives the selection of electrode for creep resisting, different creep resisting material. Now in our next class, we'll be discussing about the development of 9 to 12 chrome creep resisting steel. So thanks for watching. Please keep watching this video lecture series.